All right, so these are partial fractions, and I'll do one method and I'll do a different method for B, so you can just see which one you like. So we want to break up the fraction, and in A we've got 2x plus 3 over x minus 1, x minus 2, and 2x minus 3. All right, so these are all linear, x minus 1, x minus 2, 2x minus 3, so I'll just, the top can be a constant, so the top's 1 less power. So the top is going to look like this. If I, oops, that's a negative 3. So if I'm just looking at the top here, then what I'm doing is having a look at this. This one, if I put it all on the same denominator, I would need to times it by those two brackets. For B, I would need to times it by these two brackets. And for C, I would need to times it by these two brackets. Then it would all be on the same denominator, and now I'm just ignoring the denominator on both sides. All right, so what we could do for this is a few different things, but for example, you could sub in x equals 2. When you do that, on the left-hand side, you get 2 2s are 4, 5, 6, 7, so we get 7 equals. Now that's nice because it gets rid of, you get a 0 here, so it gets rid of that one. You get a 0 here, so it gets rid of that one. So all you've got left is B. And if I sub in 2, 2 minus 1 is 1, and 4 minus 3 is 1. So I just get B. So that one just gives me B is 7. I could do the same thing with x equals 1, for example. So on the left-hand side, I've got 2 1s plus 3, so I've got 5. And on the right-hand side, it gets rid of the B and the C terms, so I've just got the A term. When I sub in 1, I get a minus 1 for there, and then let's just get rid of that, minus 1, and then 2 1s minus 3, I get another minus 1. So you can see straight away there that A equals 5. So that's a nice way to get the A and the B. The C, so we could do another substitution, or you can use some substitution, then you can use coefficient, for example, the coefficient of x squared. So if I look on the left-hand side, there is no coefficient, there's no x squared, so the coefficient is 0. If I look on the right-hand side, I would have to have 2a x squared, so I'm just doing that times that to get my a squared term. So that'll give me 2a's, and then I'll do that times that times that. That'll also give me 2b's. And then this times this would give me my x squared term, which is just a c term. So from that, you can see 2a's would be 10, 2b's would be 14, and then c. So what are we going to get from that? We're getting c equals negative 24. So if we put that back in, so we've got A is, and I'm not going to write it properly here, so I'm going to change this A to a 5. I'm going to change this B to a 7 and the C to a minus 24. Okay, so instead of doing the integral of this one, I'm doing the integral of this. So I've broken up the fractions. Now when I do that, you'll see I've got the integral of, if I put the 5 on the front, I've got x minus 1 dx. Then I've got plus 7 x minus 2 dx. Minus 24, except I need a 2 at the top because the derivative of 2x minus 3 is 2. So I'm going to say minus 12 and put a 2 at the top on 2x minus 3. So that makes it, so that's what our integral equals, and that's nice because we've got a 5, oh, my pen is starting to not work. All right, we've got a 5x minus 1 log of x minus 1, we've got a 7 log of x minus 2, and we've got a minus 12 log of 2x minus 3 plus c. Okay, so that will be your solution there. Okay, so let's do a different method for B. Let's have a look at B and do a different method. So let me just pull this across. and have a look at b. Okay, so again, we want to do partial fractions. We do need to factorise the bottom. You can do PSF. You can see they've all got x in them, so we know it's going to come out to be an x first of all, and then it's going to be an x squared term, and it's going to be x squared minus 6x plus 8. And I can see that's going to be x minus 2x minus 4. You could do that separately if you need to. All right, and at the top we've got 4 lots of x plus 3's. All right, so what does that give us? So again, if I make a over x, sorry about that, b over x minus 2, and c over x minus 4. Just like that. Now, so you can do a cover-up method, as they call it. And what is the cover-up method? So really what you're doing is, for example, multiplying, because this is an equality, if we multiply each side by x, that will get rid of that, and you'll get an x here, an x here, and x here, and that will cancel with that. So you'll see that if I make x equal 0, because it's subbing in for x, for that x. So if I make x equals 0 and just use that, you see that this term and this term will both disappear. And on the left hand side, we've got 4 lots of 3's on, so 0 minus 2 is minus 2 times 0 minus 4 is minus 4. So that's what we've got on the left, and on the right we've got a. And that's just kind of what they call covering up, because they're covering up this x here. All right, so when we do that, we get a is 3 on 2. So I'll just go like this. So a is 3 on 2. So we can do the same thing with, if I get rid of that and put my x back in, and get rid of that and that and that, I'll put my x back in here. All right, so for example, doing the cover up with x minus 2, what we're doing is taking this x minus 2 here and multiplying it on the other side for everything. So you'll have the x minus 2 there, the x minus 2 there, and the x minus 2 here. So you'll see that then if we sub in x equals 2, then this will become 0, this will become 0. Sorry, that one. This one will become 0. This one's already cancelled here, so we can get b. So we can get the answer to b. And remember, this one is not there. So if x equals 2, we can sub it in. We get 4 lots of 5's, and we've got 2 and then minus 2. So this is a b, not a 13. So what do we get for b? If we just solve that, so we've got 20 over minus 4, so we've got negative 5. All right, we could do exactly the same thing again with x minus 4. So you'll see each time, you don't have to actually write it out. You can just have a look at it and say, well, if I've got x minus 4, the only term on the right that I'm going to be left with, because they're going to cancel if it's x minus 4, the only term is c. And to do that, I've multiplied by this x minus 4. So we've gotten rid of that one, but we've got everything else on the left-hand side. And we're going to sub the 4 in. So we're going to get 4 lots of 1's. 4 plus 3 is not 1. We've got 4 lots of 7's. And on the bottom, so 4 lots of 7's. And on the bottom, we're subbing 4 in, aren't we? So we've got 4, and we've got 4 minus 2, which is 2. So you can see here, for C, we get 28 on 14. So we get a 7 on 2. All right. So then our integral becomes, I'll just write it here. So our integral then becomes, let's put the a out the front. So we've got 3 on 2, and we're just left with dx on x. Let's put the minus 5 out the front. So we're left with dx on x minus 2. And let's put the 7 on 2 at the front. So we're left with the dx on x minus 4. All right, that should be a little bit easier then. So now we've got 3 on 2 log of x minus 5 log of x minus 2, oops, plus 7 on 2 log of x minus 4 plus c. And there's your answer. So you can see that what they call the cover-up method is actually quite quick. You don't have to actually, write anything down or cross anything off. You can just do it in your head by covering each one up kind of with your thumb and doing it that way. But hopefully that helps you understand why we can do that.